Hello. Yes. So welcome back all. So again, welcome back to Gate Solution sessions, tutorial sessions. So we were doing 2021 solutions, Gate 2021 solutions uh, in session 9. So we stopped at this point discussing about singlet state, what's singlet state, and what is the expectation value of sigma dot sigma 2 for the operator on the singlet state. Actually, I have few more questions remaining in the 2021, so I will be discussing that, and I have not worked out all the questions. So the questions that I have not worked out, I will be just giving you the answers in the worked out. You can actually find. I will not be discussing, but you can find out them in the when I upload this. You can find it out, and then I will move on to 2020. Let me check this. Yes, then I will move on to 2020 question paper. Okay. So yes. So this is the next question from 2021, Gate 2021. The donor concentration in a sample of n-type silicon is increased by a factor of 100. Assuming the sample to be non-degenerate, the shift in the Fermi level in milli electron volt at 300 Kelvin, 100 of the nearest integer. Given that KBT is 25 milli electron volt at 300 Kelvin. Okay, so here I am just directly giving the formula because I'm not very used to with this kind of calculations. These are kind of condensed matter or solid state related questions. So I just got this formula. Using this formula, actually you can find out what is the shift in the Fermi energy. So the formula is given by delta E equals kBT times log of N2 by N1, where N2 is the final donor concentration. If you are changing the donor concentration, N2 is the final donor concentration and N1 is the initial. So that means if you increase the donor concentration, N2 by N1 will be higher and you will get increased delta EF, or if the other way around. Okay. So here actually given that it is increased by a factor of 100. So N2 by N1 is 100. So you can directly put that, and you directly calculate delta IF will be 25 times log of 100, which is 115 milli electron volt. I have actually attached the answer keys also. These are kind of numerical questions. You can find them in the answer key. Okay, so next question. So the spacing between two consecutive S branch lines of the rotational Raman spectra of hydrogen gas is 243.2 centimeter inverse. So after excitation with a laser of wavelength to 514.5 nanometer, the Stokes line appeared at 17611.4 centimeter inverse. For a particular energy level, the wave number in centimeter inverse at which the Stokes line will appear for the next higher energy level. Okay, so basically it's maybe if I show it some diagrammatically, E1, E2, there are two levels. They are this is what I am understanding from this question. E1, E2 levels are there, and there is a spacing between them. So wave number is basically 1 by lambda, that which is, so you know, energy is hc by lambda h nu. So h and c are constant, so basically 1 by lambda will give you its energy scale. So that's why these things are given in terms of centimeter inverse. So E1 basically gives us Stokes line at this particular wave number under the excitation from a laser of this particular nanometer. E2 will be also so the answer is like the question they are asking, there's a excited state E2. So what that it can also emit a stock line, right, due to the same laser light. So the question is that what is that corresponding stock line from E2 maybe. So this is how basically it's a idea is that even after the uh, both the stocks lines of corresponding to E1 and E2 will be again having the same spacing, right, 243.2. That's what I'm guessing. So in that case you can basically find out the wave number of the stocks line E2 as one for this minus this particular gap between them. That basically gives you this figure 17368 centimeter inverse. You can find out in the answer key. Okay, so next one, consider the atomic system as shown in figure where the Einstein coefficients A for spontaneous emission for the levels are A 2 to 1 is 2 into 10 raised to 7 per second, and A 1 to 0 10 raised to 8 per second. If 10 raised to 14 atoms per centimeter cube are excited from level 0 to level 2 and the steady state population in level 2 is achieved, then the steady state population at level 1 will be x into 10 raised to 13. So what is x? Okay, so I think this, when I worked it out, actually we have to kind of neglect some things. It's not all the details are not given, at least in the problem. So what is given is that you have three levels 0, 1, 2. There is a transition possible spontaneous emission from 2 to 1 and also 1 to 0. So they have actually excited by population inversion atoms to second excitation, I mean this level 2. So if you look at this, actually you can see the rate from 2 to 1 is 2 into 10 raised to 7, which is very less than the rate to 1 to 0. It is 10 raised to 8, at least order of magnitude different, because this is 10 raised to 8 and this one is 10 raised to 7. So this decay happens faster compared to this one. So this one is lower. So what happens is that if you actually pump some N0 atoms in this, there is this decay happens, but suddenly that get decayed to here also, right? So there is like whatever comes in, there is something coming down, so it suddenly reaches a kind of steady state. So the question is what is in that steady state level, what will be the population in level 2? So with the given, because I am now omitting, like there can be absorption, I mean kind of stimulated emission, stimulated kind of transition, but these details I am, since there is nothing given, no details are given in terms of those, we have to neglect those things. So under this assumptions we can basically see that A 1 to 0 N1. So suppose N1 is the number of atoms in level 1 and N2 is that in N2. So it should be under this steady state. So steady state should be meaning what do you mean by steady state? This should be the meaning of steady state. So whatever particle comes down here and whatever goes from here to here, if they matches, then there is a kind of population sustained population in level 1, right? At least that should be the physical meaning of that steady state. So just putting N1 equals, you just reverse this equation and you can get N1 equals N2 to 1 divided by N1 to 0 N2. So N2 actually, like it's a population in N2, you have to, it should be a dynamic quantity actually, like because of if thing goes down here and goes down here, basically it is decaying unless there is a kind of pumping from 0 to 2. It should be decaying, but you have to assume that, I think, given that this is a big number, and it's 14 atoms, you maybe have to like assume that n2 is equals 10 raised to 14, and if you put that value, you will basically get back 2 into 10 raised to 7 divided by 10 raised to. So this is basically a21 and this is a10, and n2 I am now fixing this 10 raised to 14. That will give you 2 into 10 raised to 3. Yes, so 7 minus 8 is minus 1, and 14 minus 1 is 30. So 2 into 10 raised to 13 per centimeter cube, atoms per centimeter cube. So basically here x will be 2 in that case. I think this actually the answer matches with the answer key. This should be the answer, but I kind of we have to assume several things in this problem, but I think it should be fine because there is a large number of atoms present, and it should be okay with these assumptions. So x is 2, that's the answer. And next problem. Okay, so a uniform block of mass capital M slides on a smooth horizontal bar. Another mass small m is connected to it by an inextensible string of length small l of negligible mass, and is constrained to oscillate in the xy plane only. So neglect the sizes of masses. The number of degrees of freedom of the system is 2, and generalized coordinates are x and theta as shown in the figure. If p, x, p, theta are the generalized momenta corresponding to x and theta respectively, then the correct options. The question is to pick out which are the correct options. So option says that you have to basically find out p, x, p, theta and whether they are conserved. That's the question. Okay, so let's start from beginning. Like you have to find out the Lagrangian of the system. So Lagrangian is basically T minus V. T is a kinetic energy and V is a potential. So T kinetic energy can happen. So this big block is actually moving, and this small one is actually attached to this one. So whatever motion this has, this also will have the same motion. Plus it has a kind of angular motion also. So these two motions will give rise to some the total kinetic energy of the system. So how to find out the kinetic energy? So we start from the small mass first. The small mass, actually this small m can be you can write down a position vector starting from, assume this point. So here, if you look from here, then your position of small m will be L cos theta j cap plus L sin theta I cap, and the velocity with respect to that point will be like take the derivative with respect to time. So this is basically dr by dt, and that is minus L sin theta j cap plus L cos theta I cap times there is a theta dot. It's apply the chain rule, theta is changing, so there is a theta dot. And another thing, the velocity of capital M is just x dot, how fast x is changing, times I cap. It's moving in the x direction. Now, so what is the velocity of M with respect to origin? So we have to frame everything with respect to this origin, because x is defined with respect to O, this origin. So velocity of m with respect to O is basically you basically add up these two velocities, velocity of small m with respect to capital M plus velocity of m itself. So that will give you this thing, and basically you just add this one with this one, so you will get this. Okay, so with that velocities, you have to find out what is the speed, so that you can find out what is the kinetic energy. So I am directly going to kinetic energy. So kinetic energy is basically p square by 2m, or mv square by half mv square. So that will be better because we have velocities half mv square. This formula I am using. V is the speed in that case. So the particle capital M, the block capital M have a velocity x dot. So this is basically half capital M x dot square. This is the kinetic energy of capital M, and this whole thing, this is basically the kinetic energy of small m. So what I am doing here, so you have the velocity of small m with respect to the origin we are taking. You take the magnitude of this vector, which will be basically the square of this plus the square of this, and that's what I have written down here. So there is a sine square theta, cos square theta coming in, which will add up to 1. So you will get a small m L square theta dot square by 2 from this term, and then you have a x dot square m by 2, small m by 2, that will come here. So you have a m x dot square here, and finally you have a x dot L cos theta dot term here. Okay, so there are 3 terms in the kinetic energy. And what about potential energy? So given that the block capital M is sliding smoothly on the horizontal bar, right? So there is no friction, so there is no other dissipative or any, and there is also no potential because it is changing in this direction. Whereas if M is rotating M is kind of oscillating in this way, there is a gravitational potential energy on that body. So basically the height from, if you assume, okay, so I have drawn here, if you take this to be your h equals 0, then this height will be L minus L cos theta. So this total length is L minus this part is L cos theta. So you subtract that to get the height of the bob from the h equal to 0 point. So that will be L 1 minus cos theta. That will give you the gravitational potential energy, which is mgl 1 minus cos theta. Okay, now this is the Lagrangian of the system. T minus V, this is your T and this is your V, and T minus V is take that Lagrangian. So now what you have to find out, the question is to find out Px and P theta, right? So Px is defined as the canonical momentum associated with coordinate x, which is dou L by dou x dot. Take the partial derivative, you will get there is a x dot here, m plus m x dot, 2 and 2 will cancel off, and there is a x dot here, so that will give you ml cos theta dot. So this is the Px and P theta. Find out what is P theta. There is a theta dot here and theta dot here, that will give you ml square theta dot. That is the first term, and the second one will give you ml x dot cos theta. Okay, now let's look. So the first one, Px is basically m plus m x dot plus ml cos theta dot, which is what we obtained. This is true. And P theta is basically ml square theta dot is there, but the second term is, this is not ml cos theta x dot, which is what we are getting is ml cos theta x dot, but instead of plus sign they have a minus sign. So that's why it's wrong. Now the what about the conservation, like whether Px is conserved or P theta is conserved? Okay, so for this actually, if you remember, there is something called a cyclic coordinate. So if a quantity dou L by dou Q is 0, that means Q is cyclic. So this is from classical mechanics. This means that the conjugate moment del by del q dot is conserved. Okay, so we basically use that here. So if you look at the Lagrangian, there is no x anywhere in the formula, right? So that means del by del x is 0, and which means px is conserved. But there is a theta dependence here on the potential of the block small m. So that means del by del theta is not 0 and it's not a conserved quantity. That's how you get option C is also true, whereas option D is not true. Okay, so these are the answers then. This is how we do find out the Lagrangian and just take the derivatives to get the canonical conjugate momenta px and p theta, and just look whether it is a cyclic coordinate or not, in order to get say about like the conservation, whether it is a conserved quantity or not. Okay, so next one, the normalized radial wave function. Again, these are all 2021 questions. I have not yet moved on to 2020. I think this is the last one. The normalized radial wave function of second excited state of hydrogen atom is given, where A is the Bohr radius and R is the distance from the center. The distance at which the electron is most likely to be found is y times A. What is value of y? What times Bohr factor is the most likely radius? Okay, so in spherical polar coordinates, the volume element is given by r square sin theta dr d theta d phi. This is something we all know. So the probability to find electron, so we have nucleus here and at a radius r, maybe I can put this small r, at a radius r to r plus dr, like this. So if I kind of take a infinitesimal shell of thickness dr, so this thickness is dr here, and the radius at a distance r, then what's the probability that I can find the electron in this shell? Okay, what we have to do is we have to integrate out the theta and phi component. Theta and phi has to be integrated out. So from the probability density, so I mean total probability, this again, this all you know, psi, the probability density in a volume element is basically psi mod of psi square ditto, and you integrate out theta and phi, and given that it is a normalized wave function, so theta and phi components will be there in terms of like the y, l, m, theta spherical harmonics. So that we don't have to consider because these are already normalized wave functions. So once we integrate out, you basically get a 2 pi whatever. There is some quantity which is not relevant for this problem at least. So that k is some constant times. The important thing to note here is that so r of r is given to you. So here this thing you have to take the modular square of this thing. So that will give you r square by a square. A square will be again absorbed in this constant. So you will get a r square times e raised to minus r by a only, because you are taking a square. So in a infinitesimal shell of thickness dr, this is a probability to find out an electron. Okay, so now the question is, what is the most probable distance? So if I draw it kind of schematically, this is how it looks like. It's kind of something like this. So there will be some radius r0 at which we have maximum. This is a probability density. If I plot the probability density, there is a maximum probability density to find out that. So to get that point, just take the derivative and find out the maximum, local maximum where this happens. So taking the differential, you basically have to differentiate this. So r raised to 4, how is it coming? You have a square here and also you have a square here also from the volume element. So that's how it is becoming r raised to 4. So derivative of r raised to 4 times e raised to minus r by a. Taking the derivative, you will get, apply the chain rule of differentiation, then for r cube e raised to minus r a minus r raised to 4 by a e raised to minus r a equal to 0. You can pull this common factor out, and that will give you at the end for r cube equals r raised to 4 by a or r equals 4a. So at a distance r equals 4 times the pore radius, you have maximum probability, and that's the answer. The answer is 4. Okay, so yeah, so with this I am finishing 2021. So further there are actually several questions which I am not readily able to solve this. I need some more time. I will try to, like, after these sessions, go through this and finish it. Maybe in one session I will, whatever the missed questions I will try to present. These are the questions. Actually I have this marked out the correct answers from the answer key. Numerical questions are also there, and the answer key also I have attached. So I will upload this. Now we are moving on to, like, the rest of the time. We will be having half an hour. Yeah, next half an hour we will look at 2020, the next. Okay, so next one. Yes. So as always, I will start with the GA questions. I will be only doing, like, mathematical kind of logical reasoning questions. Otherwise, I'm just skimming through them. First one is so these are grammar related questions. He is known for his unscrupulous ways. He always sets crocodile tears, that we used to say. മലയാളത്തിൽ പറയുകയാണെങ്കിൽ മുതലക്കണ്ണി എന്ന് പറയും. T is to deceive people. And second one, Jofra Archer, the England fast bowler, is more fast than accurate. That's the right answer, and select the word that fits the analogy. Build is building, and grow is not growing but growth. Okay. Question number 4, I do not think you know the case well enough to have opinions. Having said that, I agree with your other point. What does the phrase having said that mean in the given text? It's kind of like, even though I told this, I'm kind of that kind of, despite what I have said, even though I told that, I am not kind of sentence. Question number 5, define this square bracket x as greatest integer less than or equal to x for each x belongs to real line. If y equals this function, then area under y for in this interval. Okay, not a difficult one. So basically you have these tiers. From 1 to 2 the value of the function is 1, 2 to 3 is 2, and 3 to 4 is 3, because the function is defined like that. Now what is the area under this curve? So there are 3 squares, 3 rectangles having area 1 into 1, 2 into 1 and 3 into 1. You add it up and you will get 6, and you get the answer 6. Options. Question number 6 is paragraph reading or something. Go through it. D is the right answer. And for that, question number 7, P, Q, R and S are to be uniquely coded using alpha and beta. If P is coded as alpha and Q alpha beta, then what are R and S? Okay, so you have two numbers, alpha and beta. There are 4 ways to make them like alpha alpha, alpha beta, beta alpha, and beta beta. So that's option D is the right answer. Question number 8. One minute. Sum of first n terms in the sequence. Okay, so this I am not able to like parameterize kind of. I am not able to find out a closed form for this answer. I mean, the answer is there, but to derive this, so even in that case, actually, in exam oriented kind of competitive exams, you should be also try to answer it in other ways. So this is another way how you can do this. So it's just it's already given to you that the options are given and the sequence is given. So if n equals 1, that means you have only one term, it's 8, and if n equal 2, it's 2 terms, 8 and 88. So the sum will be like for n equal to 1, the sum is 8, and n equal to 2, the sum is 96, n equal to 3, and so on. So what you can do is like just by trial you try to find out which one is the actual formula. So here I am just putting by trial. I did not A and B actually. If you put n equal to 1, I am just looking for a first term, first case. AB is actually greater than 8, so I am not doing that. And CD also, C is again greater than 8, but D is actually the answer. So 8 minus, we just put the value of n equals 1 in D here, so in that you will get 80 divided by 81 times 10 minus 1 is 9, so 9 by 81 is again you get a 9 here. So 80 minus 8 divided by 9, which is 72 by 9, which is 8. So your first term is fine. What about second term? Just put one more term also. 88 plus 8 is 96. If you substitute n equal to 2 in this formula, so 80 by 81 times 99 minus 16. I have simplified this. You try it out, then you will get 880 minus 16 by 9, which is 96. So n equal to 2 and n equal to 1 both are actually fine with option D. So you can safely conclude that option D is the right answer. So even bottom line, what I wanted to say is that even if you are not able to find out a like closed form for the analytical form of answers, on an exam point of view, you can just try out options and find out the answer. It's also fine. Question number 9 now. Next time, moving on to the next problem. Select the graph that schematically represents both y equal to x raised to m and y equal to x raised to 1 by m properly in the interval 0 less than x less than 1 for integer values of m where m greater than 1. So the interval actually have property that it's 0 less than x less than 1. If m is greater than 1, then x raised to m, it's basically like if you have take a number, for example 1 by 10. If you take square, it will be 1 by 100, which is less than what you actually had. So if you raise it to a higher power, basically you reduce the number. So x raised to m will be less than x for in this interval. Now if you have if you take 1 by m, then what happened, like 1 by 10 raised to 1 by 2, which is square root of 10, which is like 1 by 10 is greater than 1 by root of 10. So this is also there. So that means, so y equal to what I want to compare with this. So y equal to x is something just right, like passing through the diagonal of this square. So x raised to 1 by m will be lying upper side, and x raised to m will be lying down. So in that way, this will be the right answer. This is the other way around, like x raised to m is upper and x raised to 1 by m lower. This is not true and this is not true. The answer is option A. Okay, so next one. The bar graph shows the data of the students who appeared and passed in an examination of 4 schools, PQ and RS. The average of success rates in percentage of these 4 schools. Basically, you just add up all the total number of passed students. It should be like 280 plus 330, 330 plus 455 plus 240 divided by the total number of students, how many they appeared for 500 plus 600 is 1100 plus again 1100 2200 and take the percentage. So 559.3. Okay, so yeah, this is the last question from GA General Aptitude. And yeah, moving on to physics problems. Question number 1 from this section: which of the following is a solution of the differential equation d square u by dx square equals k square u for k being real? E raised to minus kx, sin kx, cos kx and sin hx. Okay, so let's solve it. So this is a differential equation, u double dash minus k square u equals 0, which can be solved using the characteristics equation lambda square minus k square equal to 0 or lambda square equals k square, which means lambda can be plus or minus k. So the general solution is a e raised to plus kx and b raised to minus kx. So if you look at the options, first option is actually fine, because if you put a equal to 0, a and b can be any numbers, constants, arbitrary constants. A equal to 0 and b equal to 1 means option A is satisfied. Option B and C, these are like e to the power I kx and e to the power minus I k kind of functions. So k is real here, which is given. So B and C are not possible. What about option D? It's sin x. There is no k here. So actually you can make it sin x kx if a equal b equal 1 by 2, then this will be what u of x will be sin it of kx, but there is no k in the option, that's why this is also wrong. So only option A is the right answer. So that's option, that's our first question. Then the next one, second one: a real invertible 3 by 3 matrix M has eigenvalues lambda I, lambda 1, lambda 2, lambda 3. These are the eigenvalues and the corresponding eigenvectors EI. Which of the following statements are correct? Is correct? Option A, the matrix acting on eigenvector. This is obviously false, because given that M has eigenvalues and eigenvectors, so M acting on EI should be giving you lambda I EI, because that's the statement. But they have given is EI are the eigenvalues, eigenstates corresponding to eigenvalues lambda I for the matrix M. So this is false. Option C, M inverse will give you the same eigenvalue, which is not true. Actually option B is true. If M has eigenvalues lambda i's, M inverse has eigenvalues 1 by lambda. So this is some result from linear algebra. if m is invertible, that should be also there. If m is invertible, a given m has eigenvalues lambda i's maybe, then m inverse will be having eigenvalues 1 by lambda. So option B is true, option C is wrong. The option D is eigenvalues of m and m inverse are not, which is not true. They are related actually. So they are just like 1 by of the other, reciprocals of each other. So that's it. Question number 2. Which one of the following is a universal logic gate? It's a very easy question. NAND gate is a universal logic gate. So you can make a NOT gate with the, if this is not NAND, this is a NAND gate, and if this is X, and this will be X bar X. If not, you can produce NOT operation. And how can you produce AND gate? You just combine with you put two NAND gates. Yeah, this is X, this is Y, this is NAND, this is NAND, this will give you X, Y. And similarly with 3 NAND gates you can actually produce OR gate, X plus Y, similarly. So NAND gate is a universal gate. So basic question from digital electronics. So question number 6, which one of the following is correct binary equivalent of the hexadecimal? Hexadecimal, it's a 16 modular kind of, it's 16 base numerics. So from 0 to 9, after that you have 10, 11, 12, 13, 14, 15 corresponds to A, B, C, D up to F. Okay, so F is basically 15. 15 is 8 plus 4 plus 2 plus 1, which is this bit string in binary. 6 is 4 plus 2, which correspond to 0, 1, 1, 0. And C is 12, which is 8 plus 4, which can be represented as 1, 1, 0, 0 in binary. So just writing them one by one, you have F6C basically. This is your F6. Option B is the right answer. Moving on, question number 4. If A and A dagger respectively denote the lowering and rising operators of 1D SHM, and Keton being the energy eigenstates of SHM, given vector Keton is also eigenstates of operator A dagger AA, the corresponding eigenvalue is. Okay, so again easy question. For this you only have to remember these relations, how A and A dagger affects your energy eigenkets n. So when A acts on ket n, it lowers the eigen state, taking it to n minus 1. So it's not an eigenstate because it is changing the state, but with the factor root n. Now what happens if A dagger acts on ket n? Then it takes to the excited state. So ket n goes to n plus 1. Again, it's not an eigenstate, but there's a scaling factor root of n plus 1. Okay, with this relation you just act your given operator on the eigenket ket n. So this is how the action goes on. So first, if you act the first A on ket n, it will take one down. So basically you get root of n ket n minus 1, and again if you acting another A on the same state, then you will get the root of n times root of n minus 1 and the state n minus 2, ket n minus 2. Now you have to act to like a dagger on the n minus 2, which will take you back to ket n. So but by this relation actually it will again give you back a root of n into n minus 1 factor. So at the end you will get n into n minus 1 times your ket n. So you started with ket n and you ended up with ket n. So it's an eigenstate with an eigenvalue n into n minus 1. So option A is the right answer. So I think actually compared to previous year question papers, I found this 2020 questions easier. Okay, so this can happen like from each year to year. This depends on each year. It can be a different level of. If it is too easy, then the cutoff goes very high. If it is very difficult, then cutoff stays small. Anyway, try to like answer the at most possible within the less amount of time. Next one, a quantum particle is subjected to the potential. It's basically a particle in a box. So you have infinite potentials here and you have zero potential within minus a by 2 and a by 2. It's a symmetric well about the origin. Question is that the ground state wave function of the particle is proportional to what is the form of the wave function. So here you know that it's a cos function if it is a symmetric function, symmetric well. So this is something you should be remembering, like if it is an asymmetric well like this, start from 0 and go up to 0, then it's a sine. It's sine n pi x. Its ground state will be sine pi x by a. Okay, so that's the difference between these two. This is asymmetric. There is no symmetry, whereas this one is symmetric. So in the case of symmetric well, you have the ground state cos pi x by a. So option D is the right answer. It is proportional to up to this constant cos pi x by a. Next one, choose the correct statement related to the Fermi energy and the chemical potential of a metal. So this for the fermions, the chemical potential is actually given. You can write down them in terms of the Fermi energy Ef. I mean the chemical potential can be written in terms of Fermi energy Ef and the temperature. This is a relation. B of T is Ef minus K is some constant which involves h cut pi etc. These are all the C. C is also there, if I remember, not sure. Anyway, it's a constant. For our purpose, it does not matter. So if you put T equal to 0, you basically get mu equal to Ef. So at 0 temperature, you have your distribution function also looks like this. Right, at 0 temperature, if this is your Fermi energy, that will be your chemical potential. So chemical potential means the moment you add one particle, this much energy is required. So that's a physical meaning of chemical potential. So at T equal to 0, these are basically the same. Ef equals mu. And what about mu equals Ef at finite temperature, which is not true because mu changes. So this is not true. Mu less than Ef at 0 Kelvin, which is not true. Ef is a positive quantity. Mu greater than Ef at finite temperature is also not true. 10 more minutes. I don't know how much questions I have. Let's finish anyway the till I have solved. Question number 10. The particle is moving in a central force given by F equals minus k by r cube vector r cap. R cap is a unit vector point away from the center of the field. The potential energy of the particle is again it's a basic question. Force and potential are related as force is given by the negative gradient of potential. So or if you do the other way around, potential is given by the integral of force. So basically you bring from particle, if you remember, like in the case of gravity, you bring from a particle from infinity to a far away point to r. That's how you define your potential energy. That much work is done towards against the potential or something, against the force, like that. Okay, so you just integrate the force, given force. There's a minus sign also, that should be also remembered, because there is, if you look at the options, you have both, like the one with plus sign, one with minus sign. So minus of integral f of r dr is basically you have minus of integral minus k by r cube. So integral r raised to minus 3 dr is basically r raised to minus 3 plus 1 divided by minus 3 plus 1, which is r raised to minus 2 divided by minus 2. That's how we are getting this. The limit should be like from, we are bringing a particle from infinity to that point. That point means at r. So you get minus k by 2r square, and lower bound is 0, because r 1 by, this is 1 by r square, r equals infinity, you have 1 by infinity, which is 0. So your potential is minus k by 2r square. So option D is the right answer. Question number 14. If E and B are electric and magnetic fields respectively, then E dot B is odd under parity. So which is the right answer? Which one? E dot B, is it odd under parity or even under time? Okay, so let's see. So E, basically electric field, so there are many, it depends on what kind of charge distribution you have. The idea I want to convey is that whatever scenario you take, the parity kind of operations should be the same, right? So if you take the easiest case of a single charge, electric field due to a charge, parity operation is basically defined by this, like if you switch your coordinate system from LH right-handed system towards, it's a flipping to a LHS to RHS kind of flipping, and reverse also. So this is called a parity operation. So if you do that, basically your vector R will go to minus vector R. It's a reflection kind of about the origin. So since you have a R here, it also get that minus sign, and that means electric field is odd under parity. If you do the parity operation, you will get a minus sign. That means it's a odd under parity. But it does not have any time dependence. So whatever you do with time, like if time reversal means you make time t to minus t. But since there is no time dependence, it will be like invariant under time reversal. So invariant means it's a even parity. So electric field is having even parity under time reversal. Magnetic field. What about magnetic field? We know that it's like in the case of maybe solenoid, it's mu 0 Ni, number of turns or something. Mu 0 Ni. It's proportional to I. That's the point, or the point I want to make. Which has like time like current is defined as a rate of change of charge. So there is a time here. So if you switch your time to minus t, your current actually switches. It's minus I now. So B is basically odd under time reversal, but there is no parity. Even if you do any magnetic field does not change under parity operation. It's even under parity operation. So that combinedly, if you take E and B, E dot B, then what happens? E has a odd parity under odd parity, but B has an even parity. So odd and even will give you odd parity. Time reversal, electric field has a even parity, but magnetic field has a odd parity. So combinedly, both of them, I mean, E dot B has a odd parity and odd time reversal also. So that's why option C is true and other things are wrong. Okay, so that was the last question I have to discuss. Yeah, we are almost there. So next session we will. So this was the session. Actually, we started with session. This is session 10. So I will join you people in the session 11. From here I will start session 11. Okay, so yeah, bye. So meet you all in the next session.